Bismillahirrahmanirrahim. The topic of this lecture is selecting a sample using mixed sampling design. As previously told, sampling is the process of selecting a few, that can be individuals, that can be elements, that is called a sample, from a bigger group or the sampling population to become the basis for estimating or prediction of the prevalence of unknown piece of information, situation, or outcome regarding the bigger group. Sample is subgroup of a population you are interested in, and we have talked about different other types of sampling, that is the random sampling or probability sampling, in which randomly a sample is selected and then it is utilized for subsequent study. In non-random sampling or non-probability sampling designs, we have also talked about, in which uh, based upon the convenience of the researcher, non-random selection of sample is carried out. And today we'll be talking about mixed sampling design. Now, systematic or mixed sampling design has the characteristics of both random and non-random sampling designs. Systematic sampling is an extended implementation of probability sampling, in which each member of the group is selected at regular periods to form a sample. The researcher chooses elements from a target population by selecting a random starting point and selects sample members after a fixed sampling interval. Therefore, initially, the researcher initiates by random sampling method, selects a random sample, and then the non-random or non-probability sampling technique is applied, in which at the convenience of fixed sample, after a fixed sample, the sample is going to be chosen. In sampling, systematic sampling, the sampling frame is first divided into number of segments that are called as intervals. And then from first interval, one element is selected, that is a random selection. The selection of subsequent elements from other intervals depends on the order of the elements selected in the first interval. In systematic sampling, if the first interval it is fifth element, then the fifth element of each subsequent interval will be chosen. Uh, Please keep note this thing, that in the first interval, the choice of an element is on random basis, but choice on the elements from subsequent intervals is dependent upon choice from the first, hence is not random sampling. For example, this is, let's say, your first sequence, first interval, and you randomly, let's say, you select this number 2 house from this first sequence. This is number 2. Then intentionally you are going to, that is, our first sample is random, then intentionally you are going to select, let's say, every third subsequent element. So 1 2 3, this is going to be selected as the sample every third house, then 1 2 3 every third house, then 1 2 3 every third house is going to be selected. Therefore, the very first interval that has been selected, it is random, and the subsequent sample that is being collected, it is based upon the first sample, and is not random but in a proper sequence. However, good thing is, the scientist, the researcher, has not got no control of the subsequent samples, so any sample can be included in the subsequent sampling method. So that is the good thing about the mixed sampling technique. How does it work? Systematic sampling, whenever you're sampling, you need to ensure that you represent the population fairly. That's important in every sort of any kind of sampling technique. It is a systematic sampling or mixed sampling is a symmetrical process where the researcher chooses the samples after a specifically defined interval, and sampling like this leaves the researcher no room for biasness regarding choosing the sample. To understand it, like, another example is, you take the gym class. An instructor, he asks the students to line up and ask every third person to step out of the line. Here, the instructor has no influence over choosing the sample and can accurately represent the class without biasness. This is the good thing, with the positive thing about the systematic sampling method. And some of the questions, the very important thing which is related to each of the sampling design is that calculation of the sampling size, because students often, during their course of research, they often ask that what should be the sample size, how many cases do I need, and what weight can be a good number of sample, how many, let's say, a sample should be taken. That is always a very important question. Basically, the sample size, it depends on what do you want to do with the findings, what type of relationship you want to establish. And it is very important for testing a hypothesis or establishing an association. However, the general rule for any sample size is the larger the sample size, the more accurate your estimates is going to be. Whereas the problem is that the sample size in practice, it is predetermined by the budget that you have, the financial resources that are available to you. It it decides your sample size. However, it is very much important that if you are doing any sort of study, you need to utilize the maximum benefit of the financial resources in getting a good sample size, because a good sample size, it will then set the subsequent, all the subsequent steps and all the subsequent your finding, that will depend on a good sample size. And your skills in selecting a sample, it depends how you select your elements so that they effectively represent your sampling population. But besides getting a good sample size, it is also important that diversity or heterogeneity, or they need to be considered in selecting the sample. If your sampling, if your study design, it allows you, then it is very much important that you should diversify the selection of the sample. It's important. What are examples of the systematic or mixed sampling is, it is extremely simple and convenient for researcher to create, conduct, and analyze the sample. Very important. It's very helpful. And the samples created are based on precision in member selection, and it's free from favoritism. You do not have got the control over the selection of the sample, at least on the subsequent, samples. The first sample, you might be having some, you can say, even a researcher might be having some sort of biasness in his mind while selecting the first sample, presumably, possibly. However, the subsequent sampling, whichsoever from each subsequent interval, depends upon the first sample, it is free from biasness or favoritism. And the factor of risk involved in this method is extremely minimal. In case there are diverse members of the population, this sampling technique can be beneficial because of the even distribution of members to form a sample. Thank you so much for listening to the talk.